first of all, the first question we have to ask ourselves is this a function? And then what is the domain? And what is the range? Now, is it a function? The answer is yes. Why is it a function? Because if you draw vertical lines through the graph, it only hits in one spot. That's the idea behind how do you tell whether a graph is a function or not. Okay? And people go like this, well, that's not very hard. Well, it is if you don't know how to do it. Okay? Again, I tell you, life is filled with stuff that you would say is not very hard until you figure it out. Okay? So is this a function? The answer is yes, it is. Now, what's the domain? Put your pen on the graph and start tracing it as far left as you can trace. How far left will you get? As far left as you can go is -2. The dot there stops you. You can't go any further. So the domain starts at -2. Now how high does it go? It'll go all the way up to 3 and then it stops again. So the domain is from -2 to 3. Okay. Now, what's the range? Put your pen on the lowest part of the graph. That's as low as the graph goes. You can touch it. So it's not negative infinity because you can touch it. The lowest it can go is -2. What's the highest it can go? It can go up to 4. Okay. Any questions on that one? Let's move ahead. Now, for this one, is this a function? Again, same answers apply. Yes, it's a function. Okay? By the way, that's function for those of you watching at home. Okay? And yes, you cannot spell function without fun. I just thought that out there. How far left does it go? What's the domain? Put your pencil on the graph. How far left can you go before it stops? -2. So the domain starts at -2. Now, start going right. How far right can you go? The arrow to the right means this is going to continue on and on and on. I ran out of pen. And on and on and on and on. Never mind. Okay? So how far does it go? Infinity. Okay. Now, what's the range? Put your pen on the graph. Go to the bottom of the graph. Where does the bottom of the graph occur? -2. Where does the top of the graph occur? It goes on and on and on. So the same rules apply, -2 to infinity. Now again, I desperately need you to see this because people jack this all to hell on test day. And I know that some of you are sitting here and you're watching this on the screen and you're thinking, I got this. This is a piece of cake. Yeah, that's all fair and good. Especially if you did just what you did well on test 1, you're feeling good about yourself, and you're watching this and you're like, this is cool. All right, test 2 ain't multiple choice. And for those of you that have heard rumors about the test that I give, and you're sitting here right now going, no, that stuff's not true. Okay, test 2's coming. All right, and this is on tape, and I know that. Test 2's coming. So I'd be ready. This is not easy. This confuses the hell out of people all the time. And here's the reason why. These two infinities, I'm going to highlight it. Just because I can. Are different infinities. Like, people go like this. No, they're not. You wrote them both the same. No, those are two totally different things. You see, the infinity that you see with the domain has to do with the fact that this graph is going... That was bad. That was the wrong button. Undo. Okay. I'll do this one instead. This is even better. This has to do with the fact that the graph starts here and goes all the way to the right forever. That's this one. You need to see that. That's the reason why I put infinity, because the graph starts here and goes forever. The reason I put this to be infinity is because the graph starts here and goes up forever. So this infinity here, oh, look at there. That infinity there is because it goes up. And the next one's going to maybe possibly trick you up. Watch. This one. Is it a function? Yes. What's the domain? Negative infinity to 3. Now, why is it negative infinity? It's negative infinity because it's starting here and it's going left. It's as far left as you can go. You see, if you were to trace this graph, how far left would you go? Well, you'd be going, again, notice this. You're going this way. This is going that way. It's just going on a diagonal instead of straight across. That's where the negative infinity comes from. How far left can you go? And the answer is, uh-oh. What was that point I had? 3, 4. Okay. That's where the negative infinity comes from. Now, what's the range? Negative infinity to 4. Okay, negative infinity to 4. Just real quick, what is this one? Domain is negative infinity to infinity. Range is negative infinity to infinity. Okay. I want to pause here. Pause and explain it to you. This graph when you read this, the domain is negative 5 to infinity. Why? If you put your cursor on the graph and you start tracing back, how far left will you go? Well, the furthest left-hand point you get to is negative 5. So hence, that's the reason for the negative 5. Now, how far right does it go? As you look at it going to the right, how far right does it go? The graph is continuing at this diagonal pace, but it's always going right. And how far is that? That's the infinity that you see. Okay? That's the infinity that you see. Okay? Now, as you take your cursor and you take your pencil and you move to the bottom of the graph, where's the bottom of the graph appear? Well, it's down here. You can't even get to it because the arrow keeps pushing it further and further away. So that's negative infinity. How high does it go? Up to 3. Negative infinity to 3. Okay. Lastly, I'm going to do these for you because I got another discussion I have to have with you. Is this a function? The answer is no. Why? Fails the vertical line test right there. What is the domain? The domain is negative 4 to infinity. Why? Because the graph starts at negative 4 there and it goes all the way to the right. So that's negative 4 to infinity. Now, what's the range? The range is negative infinity to infinity. Why? Because this arrow here that's pointing down is going to go down, 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 and it continuously go down forever. There's nothing that's going to stop it from going down, so eventually it ends up at negative infinity. This arrow here, how tall will it go? It'll continue to increase and eventually go to infinity. So the range is negative infinity to infinity. Okay? All right. With that being said, let me stop this.